Dear students, I welcome you all after a long days. In next in previous class, I have told you to read a Dalton atomic theory, compound and the basic concept of this lesson. Now let us discuss the next chapter, lesson number 4. This chapter, name of this chapter is Measurement of Matter. This chapter belongs to the branch of chemistry. At the end of this lesson, we will able to learn laws of chemical combination, atom, shape, mass, valence. Next one, molecular mass and concept of mole and radicals. Now, let us begin with introduction, that is a Dalton atomic theory. Already we have learnt this in a previous standard, but also let us discuss who is a Dalton. He is a scientist. He found what is atom. A matter is made up of a tiny particles called atoms. Atoms are invisible and cannot be created or destroyed in a chemical reactions. Means we cannot see the atoms, but also we cannot neither be create or nor be destroyed at the time of chemical reaction. He explained. Next one, atoms of a given element are similar in mass and properties. Fourth one, atoms of a different elements have different masses. Means each and every element have a different mass and also a different in their properties. And next one, the atoms combine in a small whole number ratio to form a compound. Means here one or two atoms combine to form a compound in a whole number ratio. He explained in this theory. In a given compound, the relative number and kind of atoms are constant. In any the compound is formed, here the atoms are in a constant ratio, we can say. This theory is derived by the Dalton. Now come to our portion. First is law of chemical combinations. In a law of, what is meant by here law of chemical combination? The composition of a substance changes during a chemical change. The fundamental experiment in this great regard were performed by a scientist in 18th and 19th century. While doing this, they measured accurately. At that time, they measured in 19th and 18th century only at the substance used and formed. The scientist Dalton, not only a scientist Dalton but also Thomson, Rutherford studied the structure of substance and the atoms and thus discovered the laws of chemical combination. The scientist could then write the molecular formulae. Then after they studied first, then after they arranged their, then after on the basis of Dalton atomic theory, which we have discussed now only, the laws of chemical combinations, here we shall verify. Already they have prepared the law of chemical combination. Now by the chemical combination by the means of a molecular formula. Now let us, that is a law of conservation of mass, we can say. See, what is here a law of conservation of mass? Conservation means we conserve the energy at the time of reaction, or in that we can, in other words we can say, states that mass can neither be created or not be destroyed in a chemical reaction. Already I have explained in Dalton atomic theory. This means that during a chemical reaction, the sum of the masses of the reactant and products remains unchanged. To verify this law, here one activity is there. Let us see this activity. Take some sodium sulfate solution in a conical flask. See here, these are the conical flask, and some barium chloride solution in ignition tube, like test tube we can say. Hang the ignition tube in the flask by a thread and put a cork on the flask. Find the mass of the flask on the balance. Then tilt the flask. A chemical reaction takes place. When we add these types of solution, when we tilt the flask, here the both solutions are mixed, and then find the mass of the flask again. When we weigh again, once again, it will be seen that sum of the masses of the reactant and products remains unchanged. Means here reaction is getting, but also the masses are same. We can prove by this activity. This is called as a law of conservation of mass. That is, a mass can neither be created or nor be destroyed in a chemical reaction. Now let us discuss the next law, that is the law of constant proportion. See, in the law of constant proportion states that in a chemical compound, the elements are always present in a definite proportion by mass. Means in any chemical compounds, they have a definite proportions, that is we can say in a constant by the mass. For example, in water, the molecular formula is H2O, always contains two elements of hydrogen and one atom or one molecule of oxygen combined together in the same ratio of 2 raised to 16, or we can say ratio, or 1:8 by mass. Here 2 ones are 2 eighths. If 9 gram of water is decomposed by, we get 1 gram of hydrogen and 8 gram of oxygen. Means here not only the water but also the ammonia, that is NH3 molecular formula, always contains two elements of nitrogen and hydrogen combined together in the same ratio, that is 14:3 by the mass. See, this is a molecular formula. Water molecules, oxygen combines with two molecules of hydrogen, that is a H2O. Here ammonia with figure with the molecular formula with atom also I have taken the pictures. Let us concentrate on this. See, these are the examples, and we can say examples of to show the law of constant proportion. Dear students, today we have studied the basic concept, that is Dalton atomic theory, law of chemical combination, law of conservation of matter with the activity, and also a law of constant proportion. I have given here one assignment, and solve these 3 questions in your notebook. Thank you, students.